Okay, it's the appointed hour. Time to talk. Today we're going to go over the test, the old test, and I'll post this to La Lima today about an hour after class. I typically don't, but I'm going to email everybody with this one attachment. But you guys know where to find this stuff in the lecture archive, don't you? No? Okay. But I'll email everybody anyways. So any questions or anything before we start? So the test is going to look similar to this. Some of the questions will be the same with the numbers changed. Some will be completely different, but the format, so the format looks like you're going to have more space. So it's some of the recommendations students wanted. They wanted more space in between the questions. So you get more space in between the questions. And you also can have partial credit. So show your work for partial credit. Okay. And you don't have to memorize anything. So how many of the following compounds are soluble in water? What you will get is you'll get this chart. Okay. So you don't have to memorize the solubility rules. So you will get that chart. And which of the following are soluble in water? This one here is insoluble, that one's soluble, soluble, soluble. So all alkalis, all ammoniums are soluble. And hydroxides tend to be insoluble. So there's one, or how many of those soluble? Oh, how many of these are soluble in water? It's three. Three of them are soluble. So questions with this one? All right. So fictional elements is found to have three naturally occurring isotopes with their natural abundances shown here. The way you solve this problem is formula sum of the masses times the abundance. So this equals 22.176 times 0.45 for 45% plus 23.1847 times 0.45 minus the last one, 24.1934. Like so. Do you want me to do the calculation? Raise your hand if you want to see the calculation. Okay. No one wants it? Okay, that's fine. I don't know what the answer is. 2 is A. So, questions with how to do this one? So what precipitate is most likely to be formed from the solution containing barium plus 2, sodium plus, hydroxide minus, and carbonate? So when these mix, barium's going to mix with hydroxide and carbonates. Sodium, all sodium salts are soluble, and you have to look between these two, between barium hydroxide and barium carbonate. And if you look at the chart, it'll say that the hydroxides tend to be insoluble, except for barium hydroxide, slightly soluble, and carbonate is always insoluble with exceptions of, so here you go. Anyways, so these tend to be insoluble. Hydroxide pairs with barium is slightly soluble, and the next one over is carbonate, and carbonates are insoluble with except for alkalis and ammonium. So because of that, the most insoluble one is the carbonate. Because remember, this is slightly soluble, and this is definitely insoluble. So the most likely formed. They'll probably, barium hydroxide will probably also form, but it'll be mostly barium carbonate. So Questions with that one? Again, you get the chart. So what volume of 0.887 molar magnesium fluoride is needed to make 750 milliliters of 0.0224 magnesium fluoride? So the way you solve this one, use the equation M1V1 equals M2V2, or solving for V1 is equal to M2V2 all over M1. So this is just, and again, you have the equations. Molarity is moles per liter times volume liter. That's moles. Moles equals moles. That's basically what it's saying. The moles do not change, and you put in the numbers. M2, so 275.0224. Other 0.00. Oh, too many zeros. Like that. I'll make this prettier. Do you see this? Whatever the heck that is. Questions with how to solve that one? Okay, empirical formula. So we have 2.64 grams of carbon, 0.444 grams hydrogen, 3.52 grams oxygen. So first one times mole carbon to 12 grams carbon times mole hydrogen to 1 gram hydrogen times moles oxygen to 16 grams oxygen. You get a periodic table too. So, and you know where I'm getting these numbers from, right? You can see the bottom number there on oxygen. I know it's far away, but it's 16. Carbon, well, 15.99. Carbon's 12.011 or 1. Right, you got that. So now I put this in our calculators. Yeah, 2.64 divided by 12. This is 0.22. This is 0.44 mole hydrogen. I think this is 0.22 as well. 3.52 divided by 16. Yep. 0.22 moles oxygen. So now we divide by 0.22, and we get 1 to 2 to 1, or CH2O as the empirical formula. So you see how I do that? You're given mass of something, convert to moles, divide by the lowest number of moles, then get the whole number ratios with that one. Questions with how to do this one? So determine the percent yield of a reaction that produces 28.65 grams of iron when 50 grams of iron oxide react with excess aluminum by this reaction. So the percent yield is equal to the actual all over the theoretical times 100%. So we have to figure out what the theoretical is. The theoretical one is, and we know that iron is a limiting reagent, or iron oxide, sorry. 50 grams Fe2O3 times mole Fe2O3. Okay, so 2 times 55.85 plus 3 times 16. $159.7. $159.7 grams Fe2O3. Then let's see here. So then there's 2 moles iron per mole Fe2O3 times 55.85 grams iron per mole iron. So 50 grams, molecular weight of iron oxide to get the moles of iron oxide. There is a 1 to 2 molar ratio here, and then the atomic mass of iron. So 50 divided by answer times 2 times. This is about 30. This equals 34.97 grams, so therefore percent yield. Actually, I can take this up here. So this equals 28.65 by 34.97 times 100%. So 81.9. We got 92. We got 81.92%. So questions on this one, you have to figure out the theoretical yield. You're given the fact that iron oxide is the limiting reagent. So you get the theoretical yield of iron, and then to take the actual divided by the theoretical times 100% gives you the percent yield. Questions with this one? You guys are giving me blank faces. Are you following? Any questions? Good? Okay. It's a good time to ask. We have lots of time. I got through it in 45 minutes for their morning class. And we're already a third of the way through, or almost a third of the way through, and it's 15 minutes into the class. So you can get let out early, or you can ask all sorts of questions. Yeah?
So we're going to have the formulas for these, like, you know how in 50 grams and you set it up like the times and divide, like the table, how we learn how to do that?
I'm not gonna give you that.
All right, so we're supposed to.
Yeah, you have to know how to do dimensional analysis.
Okay.
You will get that. Other questions? Oh, okay. What species is by the following information? So if there is 12 protons and 10 electrons, you know it's going to be +2. So that's the first part. So you know it's plus 2 from that. And the 12 protons, you look to something that has a 12 atomic number, it's magnesium. Magnesium is here, number 12. So 12 there means atomic number 12, which is magnesium. And since it's got 2 fewer electrons, it's a plus 2 charge. So it's that one. Questions with this one? How that works? So how many moles of copper oxide can be produced from 9 moles copper 1 oxide by this following reaction? So you can look at this, it's a 2 to 4 molar ratio or a 1 to 2. So it means that you make twice as much as this, so it's 0.9 times 2. You can do it that way. Or you can do it this, so 0.9 moles Cu2O times 4 moles CuO over 2 moles Cu2O equals 1.8 moles CuO. So if you want to do it that way and just can just use the numbers, I can even move it so it's closer. From the balance equation, like so. So whichever way works, you can use it by, it's called inspection. If you look at it and inspect it and then do logic, or you can write out the long way that way, whatever way works. So questions on how to solve this one? Okay. Oxygen is light blue. I'm going to do light blue for this one. Actually, it's even lighter blue than that. How many grams of oxygen are formed when 6.21 moles of potassium hydroxide are formed? Okay. So 6.21 moles KOH times mole O2 to 4 moles KOH times 32 grams oxygen per mole oxygen. So what's that going to be? It's going to be 49 points. So that's going to be like close to 50. Yeah. So doing this, it's going to be A. But again, do you see this? How many grams of oxygen with 6.21 moles potassium hydroxide? So 6.21 moles KOH, mole O2 to 4 here by that, and then 32 grams per mole. So that way. So 6.21, so then there's a 1 to 4 molar ratio and 32 grams per mole. Questions with this one? Okay, next one. So this bottom number is the number of protons. This top number are the number of protons plus the number of neutrons. So there are 18 protons, and so since there's no charge, number of electrons equals the number of protons. So electrons equals 18. Number of neutrons is equal to 40 minus 18, which is 22. 18 protons, 22 neutrons, 18 electrons. So this bottom number, it's the number of protons, the atomic number, top number, mass number, number of protons plus the number of neutrons. So there's no charge on there, so that means the protons and electrons are the same. The neutrons, it's this number minus this number, so it's 22. I think that's argon. 18 protons, 22 neutrons, 18 electrons. Questions with this one? Okay, balance the chemical reaction here. And determine the moles of iodine that reacts at 30 grams of aluminum. So, balancing it. So, 2 aluminums, 6 iodines, 3 times 2 are 6, and it's balanced. So, is everyone good on how to balance the equation? So, 30 grams aluminum times mole aluminum to 27 grams aluminum times 3 moles iodine to 2 moles aluminum. And that's going to be a little bit bigger than 1.5, so it's probably B. Yep. It's the Z bar. I'll round it up. So that's this one. So 30 grams aluminum, balance that. And again, you get the periodic table. You don't have to memorize the molecular mass of, or the atomic weight of aluminum, unless you want to. You might, it's a good flirtation tip when you're at a bar and you're talking to somebody. Like, do you know what the atomic mass of aluminum is? Well, I do. It works every time. So, but for those of you that don't have the skills, you can just look at the periodic table when it's handed to you in the test. So, but anybody have any questions with this one? Okay. All right, next one. These students, a lot of students hate this one. Okay, I'll do it black. Density of ethanol is 0.789 grams per milliliters. How many milliliters of ethanol are needed to produce 15 grams of carbon dioxide by this chemical equation? So the way you do this is you start with what you know on the left, and work towards what you need on the right. What you need is milliliters of ethanol. So we need milliliters of ethanol. And we start off with 15 grams CO2, so times mole CO2 to 44 grams. So hopefully I've got you knee-jerk reaction, the thing, okay, moles. Think about moles. And now there is 1 mole C2H5OH per 2 moles CO2. And then we have mass. So C2H5, this is 2 times 12 plus 6 for hydrogen plus 16. So 24, that's 30, 46. So 46 grams C2H5OH all over mole C2H5OH. And this is the last step that gets people messed up. Milliliters C2H5OH to 0.789 grams C2H5OH. And if you see the way this is written, the grams CO2 cancel, the moles CO2 cancel, the moles ethanol cancel, and the grams ethanol cancel. And you are left then with milliliters ethanol that you need. Should I highlight it? And you're left with what you need. And so a lot of people have a hard time dividing out, remember to divide out the density. And the trick is with dimensional analysis, like I said, start with what's given to you and then work your way towards what you need. So in this case, what you need is milliliters of ethanol. The answer is 15 divided by 44 divided by 2 times 46 divided by 0.789. 9.94. So this equals that one there. Questions with this one? Okay, which of the following pairs will form a precipitate when mixed? So you'll get the chart, of course, and in the chart, all alkalis and all ammoniums are soluble. So this one here, the ammonium carbonate and lithium nitrate. So all ammoniums and all alkalis are soluble. That's going to do a whole lot of nothing. Okay. Also, all nitrates, all acetates are soluble. So this means silver nitrate and copper acetate, those are both soluble. Nothing happens. And lithium nitrate, nothing will happen. Mercury 2 iodide, so halides tend to be soluble. Soluble, except silver, Hg2, and lead. And Hg2 is an exception, which implies Hg2I2 is insoluble. And because of that, you're going to have it precipitate. That will in fact come out as solution. And same thing, all alkalis are soluble, so lithium and sodium, mix them together, nothing's going to happen. That's the only one that's going to form a precipitate. And again, you get the chart. Don't have to memorize a chart. That's another good flotation technique, like I've mentioned. Everyone is always impressed by that, without fail. But you won't have to remember that for the test, because you'll get the chart given to you. You have to know how to read the chart. So hopefully your test anxiety is not so bad that you forget how to read. There's some people that get that way. There have been cases of students getting tests, especially finals, and they can't even read the test, and they see it as a blank sheet of paper. Like, why are you giving us a blank sheet of paper? And it's just because the student has such bad test anxiety. That's the extreme cases, though. So hopefully no one's that bad. And if you are that bad, I'm going to bring chocolate, and apparently that also helps. So maybe you'll eat some chocolate, and then you'll later read it. Like, whoa, it's a good magic trick, yeah. My anxiety is gone, and I can see the test now. All right, so questions with 13? Nope. 14. How many molecules of hydrochloric acid are formed when 50 grams of water reacts to the following balance equation? Assume excess. So, way you solve this one, so 50 grams of water, same old dimensional analysis, mole water to 18 grams water, and then there are 5 moles HCl per 3 moles water, and then molecules. And so then there are 6.02 times 10 to the 23rd So 50 grams water, that starts off with mole water, 18 grams of water. That's just 2 times hydrogen, which is +1, oxygen 16, so 18. The 5 moles HCl to 3 moles water there, and then multiplying by Avogadro's number, which gives you molecules per mole. And since we have time, I'm going to go ahead and calculate it out. I feel like I'm doing something. This is 2.89. Oh, that's right there. Like so. Questions with this one? Probably loving this one. The sodium azide. And there's a problem exactly like this in the test, except the numbers are changed. So, azide reacts to form sodium plus 3 nitrogens. How many moles of N2 are produced with 2.88 moles of azide? So 2.88 moles NaN3 times 3 moles nitrogen to 2 moles NaN3. And I'm getting that from the equation there. And that's going to be plus 1.44, which is going to be 4.32. Yep. Like so. Questions on how to do this one? Oh man, it's a long one. Determine the limiting reagent and mass of nitrogen that can be formed to 50 grams N2O4 and 45 grams N2H4. Hydrazine, rocket fuel. Some possibly useful molar masses are as follows. Those actually are very useful. So you have to do this twice and figure out which one's the lowest one. So, so 50 grams N2O4 times mole N2O4 to 92.02 grams N2O4 times, we want mass nitrogen, 3 moles N2 to 1 mole N2O4, 28 grams nitrogen per mole nitrogen. Same one for hydrazine, 45 grams N2H4 times mole N2H4, however, 32.05 grams N2H4 times 3 moles N2 to 2 moles N2H4 times 28 grams N2 to mole N2. Like this. And I'm getting the ratios from the balance equation. 3 moles nitrogen to 1 mole dinitrogen tetroxide, or N2O4. 3 moles N2 to 2 moles N2H4, also known as hydrazine. I guess I call it dinitrogen tetrahydride. So you have to throw this into your calculator because you don't. I don't know what the answer is. I mean, I just did this at noon. I know the answer is the hydrazine, but that's just because I just did it. This is 45.64. Okay, 45. Oh wait, how's the top one? Oh jeez. I remember it incorrectly. Memory's not as good as it used to. Answer's B. Let's take the lower one. So, questions with this one? Yeah. Okay, oxidation number for chromium and K2CrO4. So, what you get you're going to get this. So you don't have to memorize the rules for assigning oxidation states. You will have those at your disposal. So the chromium atom, and it's going to be 0 is equal to 2 times potassium plus chromium state plus 4 times oxygen. And potassium tends to be +1, oxygen tends to be -2. So this is 2 times +1 plus chromium state plus 4 times -2. So this means 0 equals 2 plus Cr minus 8. 0 is 2 plus Cr, or let me just write the same thing, is Cr minus 6. 6 is equal to Cr. So it's 6. Questions on how to do that one? Do purple. We haven't done purple yet. How many molecules of sucrose are contained in 14.3 milliliters of a 0.14 molar sucrose solution? So this is just meant to throw you off. You don't even need that information. So dimensional analysis again. 0.140 moles sucrose per liter. And then we have 14.3 milliliters times liter to 1,000 milliliters, and it wants molecules, times 6.02 times 10 to the 23rd molecule sucrose over moles sucrose. So if you look at the units, the moles sucrose cancel, the milliliters cancel, the liters cancel, and you're left with molecules of sucrose. So that would be 10 to 20, 14 times 24. So that's going to be about 9 times 10 to the 20th. Okay. So it's that one. Like so. Questions with how to do this one? This is just extra. You can't see that. That's just extra information. You don't even need that. That's just there to throw you off. So it's an acid of half a mole of dichloro-difluoromethane So this here, it's 12 for carbon times 1 plus 35.45 for chlorine times 2 plus 19 times 2 for fluorine. So that's 60 plus 9. So this is 130. So we have 0.5 moles of CCl 2F2 times 130.9 gram CCl2F2 per mole CCl2F2, which is equal to 60. What did I do something wrong? What is it? Yeah, but I wonder if I calculated the mass of the thing wrong. Oh, it's 50. Is that what I did? Wait, 19 times, that's 38. It's 120. 60.45. There we go. 2 times 2, yeah, that'd be 38 plus 12, that's 50. Yep, okay. All right, now I got it. Alrighty. So, questions on how to do that one? Alright, and there's another one that's just like this, number 20, but it's a different molecule, it's not fluorine. So, as I already discussed, so 19 times 2 is 38 grams per mole, so 38 grams fluorine per mole fluorine times mole fluorine to 6.02 times 10 to the 23rd F2 molecules. And so doing this is going to get you 6.3 times 10 to the minus 23 grams fluorine per that one there. So we're going to divide by Avogadro's number. And that's it. I kept you 3 minutes longer. That's like 3 minutes longer than the first class. Remember, it was 45 minutes. Anybody have any questions about anything? It's because of those 2 questions you guys asked. Just kidding. Alrighty. So no one has any questions? You guys are free to go then. Don't forget, test on Wednesday. Oh, and you guys got my email about the homework issues? I'll fix it. If you send me the stuff, I'll fix it. I thought I fixed it by changing the dates, but that apparently didn't work.